We're live. Okay. So the first section in this packet is not, we've already talked about this, is characteristics of life. So we're going to go straight to section 2, the atom. You watched a cool video. I thought it was cool from Ted Ed about the atom. Okay. A lot of this you had in 8th grade, correct? All right. Some of the first section, you were probably, all right, now why is that screen? Why is it doing that? We did this yesterday. We're still recording. Hello, hello. Test, test. All right. So, atoms are made up of protons, neutrons, and electrons. The mass of the atom is located in the nucleus. That's where the mass of the atom exists, in the nucleus. The nucleus contains the protons and the neutrons. The electrons are orbiting around, like the picture of this scientist guy holding an atom. Okay, the nucleus is in the middle. It contains the protons and neutrons. And then the electrons are orbiting around these little dots around the nucleus. Okay. Which subatomic particles are positively charged and which are negatively charged?
Protons are positive and electrons are negatively charged.
Is that what you were going to say, Isabel?
That's what I was going to say.
Yes. Sorry.
Very good. Now, atoms are neutral. Okay. Atoms are neutral, which means that the positive particles are equal to the negatives, right? If it is an atom, then it's going to have an equal number of positives and negatives. So if I said carbon, the atom, has 6 protons in its nucleus, how many electrons does carbon have?
6.
6. Because atoms are going to have an equal number of positive and negative particles. So if it has 6 protons, it's going to have 6 electrons. If protons are positive, electrons are negative. Doesn't necessarily mean it's going to have the same number of neutrons. Okay? So remember that, because if an atom has a few different versions and some different versions have a different number of neutrons, those are called isotopes. And we'll get to that in a minute. Okay? Here's a good picture of an atom. You're going to have to draw some pictures of an atom for homework. We'll have a quiz on Tuesday when you come back on these first 2 sections. So study for that. Quiz on Tuesday, Wednesday. I want to see y'all to Wednesday. Okay? All right. No school Monday. We'll come back on Tuesday, Wednesday. A-Day Tuesday, B-Day Wednesday. We will have to refer to the periodic table to do a lot of things during this inorganic unit. Okay? And you need to be able to identify where the atomic number is. And generally, on the periodic table, in the little squares, it's, like I say, if we do carbon, it'll be in its own little square, and there'll be a number somewhere, depending on where they put it. But that's the atomic number. That equals the number of protons. Okay? Equal to the number of protons. The mass is what's in the nucleus, which is 2 things. What's in the nucleus?
Neutrons and protons.
Protons and neutrons, okay? The atomic mass is the mass contained in the nucleus, which is equal to the protons plus the neutrons, right? The levels of energy outside the nucleus are called energy levels, and they contain the electrons, the negative particles, all right? All right. Here's a good picture of what carbon would look like on the periodic table. Just a generic. Okay, you need to know which is which here. Here's your atomic number. Here's the symbol. Here's the name. Here's the mass. And there's the number of electrons. Okay, and what this is telling us is these are the electrons in the first energy level, and these are the electrons in the second energy level. And I'll explain that to you when I talk about drawing atoms. Okay, the mass equals what?
Equals neutrons plus protons.
Yes, that's algebra right there. P plus N. Mass equals P plus N. All right. If mass equals P plus N, then you could also say that N equals M minus P. Yes, you could. If mass equals protons plus neutrons, then you can find any of these as long as you're given the other. Okay? So neutrons equals the mass minus the protons. So if you don't know the neutrons, you can figure that out by taking the mass and subtracting the protons. If the mass equals the protons and neutrons, then the neutrons equals the mass minus the protons. Right? Is that algebra or what? Didn't think you'd be learning about algebra in biology, did you? Got to use it all over the place, man. Okay, and there it is again. It's right there for you, all written down in your notes. Okay, that's section 1, section 2. Okay? Now I'm going to show you real quickly. I'm going to talk to you about an isotope and then drawing atoms. Okay? So atoms. Are atoms neutral? Yes. They have a neutral charge. Okay? Which means, i.e., protons equal neutrons. Protons equal electrons. Okay? Positives equal negatives. That's an atom. An ion is an atom that has a charge. Okay? Atom with a charge. Can be positive or negative. For example, when table salt is formed, it is a combination of those two atoms. But when they bond with each other, to do so, sodium gives an electron to chlorine. Okay? So sodium is going to give a negative to chlorine, giving chlorine one more negative. By losing a negative, sodium becomes positive. And once an atom gains a charge, whether it's positive or negative, it is not called an atom anymore. What is it called? An ion. Okay? Covalent bonds form between atoms. Ionic bonds form between ions. Okay? Remember that. Covalent bonds form between atoms. They share their stuff. And ionic bonds form between ions. If there's a give and a take, a gain or a loss, then an ionic bond forms. Okay? Some atoms can have what's called isotopes. For example, carbon. There's a carbon 12, a carbon 13, and a carbon 14. These are just 3 different versions of carbon. They have the same chemical makeup. They just each have a different number of neutrons. So this one has a little more mass than that one, and this one has a little more mass than this one. Here's where the 12 comes from. The 12 means that in its nucleus it has 6 protons, 6 neutrons. In carbon 13 isotope, it has 6 protons, 7 neutrons. In carbon 14, it has, guess what? And 8 neutrons. Okay? Same number of electrons. Okay? Just a different number of neutrons. That's an isotope. There are 3 isotopes of carbon. Carbon 12, carbon 13, carbon 14. Okay? Again, this is recording. So you guys can go back and watch this over and over and over if you feel like it, if you need it. A lot of people like it, a lot of people don't. Second homework assignment, drawing atoms. Okay, we're going to draw atoms. It's in Canvas. When you click on that assignment, drawing atoms, it's going to pull up a little window. It's going to have a list of atoms that you have to draw. And what you're going to draw for the second homework assignment in Canvas, due September 5th and 6th, is diagrams called, ironically, Bohr diagrams, B-O-H-R. Okay? Now here's how you draw a Bohr diagram. We're going to use carbon again. You're going to be given, you can go look at a periodic table and find the number of protons. That's all you got to do. Okay? Find the number of protons on the periodic table. I got a little handout I'm going to give you with periodic tables on there. Okay? A Bohr diagram, we're going to draw the nucleus, and we're going to put the protons and neutrons in the nucleus. We're going to say this is carbon 12. Okay? All right, so I got my nucleus. Now I got to put the electrons on the drawing. If carbon has 6 protons, how many electrons does carbon have?
6.
6. Now, these outer levels, not the nucleus, but outside the nucleus, you have these areas where the electrons orbit, like the planets orbit around the sun. And these areas are called energy levels. All right, we call them energy levels. The first energy level is the one closest to the nucleus. It can hold a maximum of 2 electrons. That's all it can handle. Okay. How many electrons do I have to plot in my picture? 6. So I'm going to draw a dot here. I'm going to come on to the other side and draw a dot. I'm going to make sure I identify them as negatively charged particles. This is a positively charged particle. All right, I got 2. How many do I need?
6.
6 or 4 more. 2 fit here, so to get the rest of them, I've got to draw another energy level, and I need to put my other 4 here. Now I have finished drawing my Bohr diagram for carbon 12. Okay? All right, that's a Bohr diagram. You can refer to these notes when you get ready to do your homework about how to draw Bohr. Now some of them get more complicated. After the first energy level, they can hold up to 8. All right, and then they max out and you go past that. All right. So let's take chlorine. Okay, chlorine, if you're looking at it on the periodic table, it has an atomic number of 17, which tells me what?
17.
It has 17 protons. Okay, if it has 17 protons, how many electrons does it have? 17. 17p, 17e. Okay, so we got 17 positive, 17 negative. How many protons are in the nucleus? 17. Okay, how many electrons are on the outside? 17. How many fit in the first level?
2.
2. How many fit in the second?
4.
8. 8. Atoms that have stable classification, they have full satisfied energy levels. They're full with the maximum amount that they can have. They're happy, they're stable. Okay?
Does the second circle always have, like, not as many dots as the third?
Yes. Only 2 fit in the first one. This is called the first one. This is the second one. Right? All right, so we have 17 to plot, right? And how many have we plotted so far? 10. We did 2 and 8. That's 10. So how many more do I need to put? 7. So I got to draw one more energy level, and I got to put 7 on it. Okay? Now we drew a Bohr diagram for chlorine. Chlorine is not a stable atom. Chlorine gas is toxic. It is very unstable. Okay? For it to be stabilized, it needs another electron. If it gets another electron on its outer level, it has 8. And it satisfies the rule called the octet rule that says if atoms have 8 electrons on their outer level, they're stable. There's a whole group of atoms and elements on the periodic table that you guys had to learn last year. They're on the far right side, okay, on the periodic table. There's like helium, neon, argon, xenon. Y'all remember what all those things are called?
Noble gases.
Noble gases. They all are in the same group. They all have 8 electrons in their outer shells, and they never have to bond with anything else because they are stable. Okay? They don't need any other atoms. They're fine just by themselves. And they stay by themselves. Okay? Very stable elements. They're the noble gas. All right, so there's chlorine. That's a Bohr diagram. Okay? Here's why sodium and chlorine like each other so much. All right, we just drew chlorine, right? Is chlorine stable? No, because it's missing one electron. It needs to have one electron right here to be stable. So what it's going to be looking for is another atom that has one outer energy, outer electron to bond with so that it can fill it up. And sodium helps it out. Okay, here's sodium. This is chlorine. So sodium has an atomic number of 11. Right? It's got 11 protons in there. It's got 11 electrons outside. 2, 8, and stay with me. Who's following?
Me.
I'm following.
Who said that? Aaron, good job. 1. All right, so here's sodium with 1 electron on its outer shell. Here's chlorine with 7. So to be stable, atoms want to have 8 on their outer levels. So what sodium can do is say, hey, why don't you take my 1, chlorine? Here, you take this. I got a great idea. If you take my 1, then I will be stable. Because now, if sodium gives that 1 to chlorine, it doesn't have this anymore. Look what it has now. 1, 2, 3, 4, 5, 6, 7, 8. It's stable. Okay? And chlorine gained that 1 electron it needed. So now it has 1, 2, 3, 4, 5, 6, 7, 8. It's happy. But for this to happen, they have to be together. It's a deal they have to make. Okay? Beautiful woman marries an 80-year-old ugly man, and they're like, She's like, I love your $1 million bank account. And he's like, I love how beautiful and young you are. Let's get married. Okay. I get the money, and I get your beauty. Let's bond together. Let's get married. Right? One of them gets something from the other one that they want, but to get it, they have to be bonded. He can't have the beautiful wife unless he marries her. She can't have the money that he has unless she marries him, okay? So think about sodium and chlorine as an 80-year-old man and a 25-year-old model, okay? They each want something from each other, and they're willing to give it to each other, but to do that, they have to be bonded, all right? For sodium to become stable, it has to bond with something else. I don't know if that's a good analogy, but I feel like it hit home with you. Okay, probably could have come up with a better one but you know what I'm saying, right? If I offended anybody, if that's your family, I'm sorry. I didn't mean any harm by it, okay? All right, so guess what the bond's called that forms between, now, look. Sodium lost an electron. So now it's got 11 protons. How many electrons does sodium have now? 10. So we got 11 positive and 10 negatives. What's the total overall net charge of sodium? Plus 1. Sodium has become charged. So it's not an atom anymore. What's it called now? An ion. Atoms that have a charge are called ions. Okay, so now sodium, because it gave that away, it's got 1 positive. So now it's not just sodium, the atom. It's going to be written like this. And if I write that right there on a piece of paper, basically what I'm doing is I'm saying this. Sodium ion. I can write that. I can speak it. Or I can draw that picture right there. They all three tell you the same thing, that is sodium, the ion. Okay? I say it, sodium ion. I write it, sodium ion. Right? It became charged, now it's an ion. Same thing happened to chlorine. Okay? Chlorine had 17 positives and 17 negatives, but it took an extra negative. So now how many protons does chlorine have? 17. How many electrons does chlorine have? 18. Okay? So if you've got 18 negatives and 17 positives, what is 17 plus minus 18? What is a 17 plus a negative 18? Negative 1. Okay? So now chlorine is not the atom anymore. It's chlorine, the ion. And we would show it like that. It has a negative 1 charge. Some ions have more than just one, like calcium. If I write calcium, whoa now. Okay, there's calcium, the ion. Guess what I'm telling you right there? Come on.
All, yeah. 2.
That's 2, right? I'm telling you that this is calcium, and it's an ion, and how many electrons did it lose? 2. It lost 2, so it's got a plus 2 charge. So it's going to be looking for something with 6 valence electrons to bond with, like calcium chloride. Not calcium chloride. Yeah, calcium chloride would be one, but it would have 2 chlorines, 1 calcium. Okay? Magnesium oxide is a molecule that where magnesium is plus 2, oxygen is minus 2. Okay? We're going to play a game with this next week. Y'all got to draw these atoms. You don't have to do the whole ion thing, but you do have to draw the atoms, okay? Let's see if this recording worked. This is 5th block, signing off. Sponsored by Bank Plus.